As an alternative way to factor polynomials, you can actually reverse the area model, but a quick review of what it means to multiply a polynomial with an area model. You've probably seen this before and just maybe don't remember what it's called. So to start off with an area model, the idea is we can basically create a rectangle and split it into sections and use that to find the area of each part of the rectangle and then add it together to get the whole area. So I'm going to split my rectangle into 4 parts. One side of the rectangle is going to have the length 2x plus 1. The other dimension of the rectangle is going to be x minus 7. Notice I'm keeping the plus and minus signs there for my side. Now, normally we just multiply this out by multiplying each term in the first bracket with each term in the second bracket. FOIL for those of you who like to use that. But this kind of just gives us an organizational way of filling it in. So for the first box, we're doing 2x times x, which gives us 2x squared. Going to the right, we're doing x times 1, which is x. For the next row, 2x times negative 7, which is negative 14x. And negative 7 times positive 1, which gives us negative 7. So we know that 2x plus 1 times x minus 7 is equal to 2x squared plus x minus 14x minus 7. Okay, and we can actually combine our middle terms there, 2x squared minus 13x minus 7. How can we use this to factor? Well, we can pretty much just reverse those steps. So let's start off with this one since we did just multiply it and we know what it's equal to, and let's try and factor it instead. There we go. So we've got a trinomial. It's in the form ax squared plus bx plus c. We've got our first term starting with the number 2, our last term with a negative 7. Our b term in the middle is negative 13. We can follow the same kind of steps we did for decomposition and find our AC. In this case, it's our product of 2 and negative 7, which is equal to negative 14. And we know we're going to have a sum or a b value of negative 13. So I'm looking for two numbers that multiply to negative 14, but add or subtract to negative 13. Offhand, it sounds like 1 and 14 would work, so long as I make one of those positive and one of them negative. If I'm adding them together and they add to negative 13, it sounds like I should have positive 1 and negative 14. Okay. When we did this for decomposition, we then rewrote our trinomial and kind of broke our x term into those two parts. We do the same thing for an area model, but what we're actually going to do is fill in the inside of the area model because that's what we already know. We know what our binomials multiplied together are equal to, and we're trying to factor them. So we start off with 2x squared in the top left corner and our negative 7 in the bottom right corner. The other thing we want to kind of fill in there is our negative 13x, which is getting split into two pieces or still decomposed into 1x and negative 14x. But I can put those in the other two boxes and it can go either way. So negative 1x, sorry, that's positive 1x, and negative 14x. And you'll notice if you change which of the two boxes you put them in, it'll just end up going the other way. The way we can use the box method for this is we just need to find the greatest common factor for each row and each column. So let's look at the first column first. We have 2x squared and x, and we ask ourselves, what is the greatest common factor of those two terms? It's x. That's a pretty easy one. So I write that in up top. Let's look at our next column. We have negative 14x and negative 7. As soon as I notice that first one is negative, my greatest common factor should be negative as well. They're both multiples of 7, so it looks like negative 7. Okay, and now let's do the same thing for our rows. Our first row has 2x squared minus 14x. I'm finding the greatest common factor of those two terms. They're both an even number and they both have an x, so it's going to be 2x. And again, my first term, the 2x squared, was positive, so I know my greatest common factor is positive. Okay. For our second row, we have x and minus 7. Those don't really have anything in common. So what is our greatest common factor? Well, it would just be 1. In this case, positive 1, because that x is positive. So now we can actually use those two binomials we found. And that is our factored form, 2x plus 1 times x minus 7. That's exactly what we had. If you're doing this from scratch and you're not sure, you can multiply them out, but we can see that that's equal to 2x squared minus 13x minus 7. That's our other method for factoring. Let's try this again on the examples we did the other method on. Here are the same examples from last video. Let's start off with 2x squared plus 5x minus 12. So again, I can just take my first term and my last term and fill them right in. 2x squared and negative 12. And notice I'm always putting my x squared term in the top left, my constant number in the bottom right. My x terms will go in the other two. So again, just as a quick reminder, we had two numbers that needed to multiply to negative 24, and they had a sum of positive 5. So our numbers were negative 3 and positive 8. We use that to split up our x terms. So instead of 5x, it's negative 3x and plus 8x. You don't really need the plus sign in there, but it's fine if you do write it there. Now what we can do is factor each column in each row. Let's start off with the columns since that's what we did last time. 2x squared and 8x. Find the greatest common factor. They're both multiples of 2, and they both have an x, so that would be 2x. For the next column, we have negative 3x and negative 12. Both negative numbers, although as long as at least the first one is a negative number, that's enough, and they're both multiples of 3. Doing the same thing with our rows, 2x squared minus 3x. Really the only thing we have there that we can factor out is an x. And plus 8x minus 12. Looks like they're both multiples of 4 because the 8x is positive. That's going to be a plus 4. I like to remember the plus sign for the signs on those so I know that it's x plus 4 and I'm not getting confused and just writing x4. So in my factored form, I have 2x minus 3 and x plus 4, and I'm just reading those off my area model, which is really convenient. Okay, if we multiply that out to check, it should work. And it looks like it does. Those multiply out to 2x squared plus 5x minus 12, which is exactly what we were trying to factor. Why don't you pause and try to do the same thing for the next one? Quick reminder, we want two numbers that multiply to 3 times negative 20. So two numbers with a product of negative 60. We want them to have a sum of negative 7. So we're going to have a 5 and a negative 12. You can refer back to the last video for help finding those if you need them. Once we have that, we're just filling everything in. 3x squared in the top left corner, minus 20 in the bottom right corner, and our negative 7x is being replaced with 5x and negative 12x. And again, it doesn't matter which of those two goes in each place, it's just going to change the order of your factors. Let's go ahead and find the greatest common factor for each column and each row, and we're going to go a little faster this time. 3x squared minus 12x will be 3x. 5x minus 20, they're both multiples of 5, and I'm going with the sign on the 5x, so that's plus 5. 3x squared and 5x, the only thing they really have is an x. Negative 12x minus 20, both multiples of 2, also both negative, so negative 2. Actually, negative 4, sorry, greatest common factor. Sort of falls apart if we don't do that. So this time we have 3x plus 5 times x minus 4. And again, we can multiply that out to check. 3x times x will give us 3x squared. Plus 5x minus 12x is minus 7x. And plus 5 times negative 4 is negative 20. 3x squared minus 7x minus 20. That does work. So there's our factored form using the area method.